What makes a function increase or decrease? Let's take a look at the definitions. A function f is increasing on an interval I if for any choice you have 2 points, x1 and x2, where x1 is smaller than x2, so let's call this x1 and let's call this x2. We have such that f of x1 is less than f of x2. What this means is that the output of x1, let's call this the f of x1. Notice how it is pretty low, but x2 will be higher. This will be the value of f of x2. Basically, you see that the graph is increasing in that way. Okay, so if you have two x values, x1 is smaller than x2, you have such that its y value is also smaller than f of x2's y value. That's how you know something is increasing. On the other hand, a function is decreasing if you have 2 points, again, x1 and x2. Here's x1 and x2, such that x1 is smaller than x2. We have that f of x1, its value, will actually now be greater than f of x2's value. What we see is that the y value here at f of x1 is going to be greater than the y value for f of x2, because that graph is decreasing, it's going downwards. Okay, so that's when a function is decreasing. A function is constant if within the interval I you have, again, two x values. Let's call it x1 and x2. However, on this for this case, the values of f of x are actually going to be the same. F of x1 equals f of x2. Kind of showing you a zero slope, right? They have the same f of x values. F of x1 is the same as f of x2. They're equal. That's when you know you have a constant. The graph is constant on that interval. You'll answer these questions in a discussion on Schoology. Let's go on to example 3. Use a graph to determine where a function is increasing, decreasing, or constant. Determine where the function is increasing, decreasing, or constant from its graph. So let's first focus on when the function is increasing. Remember, it's increasing when the y value is getting larger and larger as the x goes from left to right. So as you can see here, the graph as we go from left to right, these y values are getting smaller and smaller and smaller. This is not where it's increasing. We see the graph is increasing as y's get larger and larger and larger. We get bigger and bigger y values in this interval here. Okay, it actually doesn't stop here. The y values keep getting larger as you go on and on and on. The y value gets larger as x moves from left to right until we get to this point right here. Then it doesn't get any larger. So we see that the function is increasing from this x value of -4 to this x value of 0. The way we represent that is only using the x values. Okay, so we have that the graph is increasing from -4 to 0, and we're going to say that these are inclusive. Okay, so we do it with brackets. The function is increasing from -4 to 0. Let's keep on going along the graph. Let's see if there's any more parts where it's increasing. The y value remains the same here, so we're not going to say it's increasing there. And as we keep going, the y value is now getting smaller and smaller, so therefore it's not going to be increasing in this interval either. Okay, so let's start over. Now let's do when the function is decreasing. If it's decreasing, we should see the y value get smaller and smaller and smaller, which is indeed happening in this territory right there. So this is going from an x value of -6, and it's going all the way to an x value of -4. It stops decreasing once we reach -4, because at that point we know from -4 on it's going to be increasing, as we saw in part A. Okay, so again, because it includes -6, it starts decreasing at -6. We're going to say close bracket, inclusive, -6, all the way to -4. That's when the function is decreasing. Likewise, as we keep going along the graph, we see it's increasing, increasing, increasing. And right here, it's no longer increasing, but it's not decreasing either. The y value remains the same. Where does the y value get smaller? Right here. It starts at the x value of 3, and it keeps decreasing until you get to an x value of 6. So we also have union that is decreasing from 3 to 6, and again, both of these are going to be inclusive. We're going to do closed brackets around them to represent increasing and decreasing intervals. All right, let's do it again, but this time let's find where our graph is constant. The graph is constant when the y value remains the same. Well, y values are changing as we go from left to right. Y values are changing as we go from left to right. Y values are changing as we go from left to right. But right here, at an x value of 0, we now see we always have the same y values. They don't change. So the y value is constant when we start at an x value of 0, and we go to an x value of 3. And again, these are going to be inclusive. The function is constant just between 0 to 3. Okay? So what you'll notice in A, B, and C is that we always describe the behavior of the graph in terms of the x values. You are only using the x values to describe functions of increasing or decreasing order. Okay, so you're not using the actual ordered pair. You're not going to say the point -4, -2 to 0, 4. No, we actually just use the x value, -4 to 0, like that.